Solving radical equations. So we have to learn to solve them and then verify possible solutions. And that's true because, whenever you solve an equation, you probably check the answer sometimes. But it's even more important with a radical because radical equations can have, like we saw with absolute value equations, sometimes they have what's called an extraneous solution, which means you solved everything correctly, but when you check the answer, it didn't check. So you have to check. Checking is part of it. It's also, how you're going to answer a lot of equations is, let me see, that is the first slide. Sometimes if you get it in a multiple choice format, checking to see whether it works is part of it. But these are the steps, and they're pretty good steps. They don't always have it exactly the way I like, but step 1, isolate the radical. Right? The only thing should be on one side of the equal sign should be the radical. And by radical, it could be something raised to a rational exponent, because that's also a way we represent radicals. Once you've isolated the radical, they say raise each side of the equation to the same power to eliminate the radical. But I usually say undo the radical. If you got a square root, how are you going to undo it? Square it. If you got a cubed root, how are you going to undo it? Cube it, right? So whatever it takes to get rid of the radical, you're going to do that. But if you do it to the one side to get rid of the radical, you got to do it to the other side. Now, in the end, that means you're essentially raising it to a power. Definitely, it will look like that when we do the rational exponents. And then you solve, whatever's left. After you've undone the radical, you could have a linear equation, you could have a quadratic, you could have different kinds of equations left to be solved. You just have to solve however you can. And then here's the part that we have to keep in mind, which is check your solution. Now, you don't always check because you think there's extraneous solutions. There's a certain kind of problem which might have extraneous solutions, but not all. You can check just because it's good math to check your answer. Right, here's the example of solving an equation. It's a radical. It's a cubed root. The radical is already isolated. Right? So there's nothing, we don't have to add or subtract anything to isolate the radical. So we move on to the next step, which is undo the radical. How do you undo a cubed root? You cube both sides. Now, in their terms, they said raise each side to a power to eliminate the radical. Okay, that's the same thing. Right, you cube a cube root, you get 2x plus 7. 3 to the third is 27. Okay, so that is a pretty simple linear equation you solve with algebra 1 algebra, right? Subtract 7, divide by 2, x equals 10. Okay, we good? Good. Ashley? Good. Catherine? Okay. So, and here's their check, right? If x equals 10 is the solution, they go back to the original equation, plug in 10, make sure that it leads to a true statement, and it checks. What if it doesn't check? Then you did something wrong. Right? At this point, you checking your answer is just going to show whether or not you made a mistake or not. Deshaun? Okay. So let's see. I'm going to do number 1, and you could try number 3. On number 1, is the radical isolated? X to the third minus 9 is -1. Is the radical the only thing on that side of the equal sign? Yes. What's with the radical? -9? That's what we mean. That's not isolated. It's got a -9 on the same side. That's not inside the radical. That's after the radical. What do I have to do to isolate that? Add 9 to both sides. So now we've got the third root of x equals 8. Right? That's right. Okay, how do I undo the radical? It's a cubed root, so I will cube both sides. So this is the third root of x cubed equals 8 cubed. X equals 520. 512. I'm taking your word for it. 64 times 8. 32. Yep. 512. So try to do the number 3 as a you try. Isolate the radical first, then undo the radical, and solve. So what's the answer? 11. Did you check it? 11 minus 3 is 8. The cube root of 8 is 2. 2 times 2 is 4. But if we're going to follow the steps, we're going to divide by 2 to isolate. The cubed root of x minus 3 equals 2. Cube both sides. X minus 3 equals 8. X equals 11. And so it's the basics of solving a radical equation. Isolate the radical, undo the radical, solve. Check. Right. So I don't always do the word problems, but it's kind of a weather one, so I had to do it. In a hurricane, the mean sustained wind velocity is given by V of P equals 6.3 times the square root of 1013 minus P, where P is the air pressure in millibars at the center of the hurricane. Estimate the air pressure at the center of the hurricane when the mean sustained wind velocity is 54.5. What are we supposed to do with that 54.5? Well, there's only two things you can do with it, right? You're either going to put it in the place of P, or you're going to put it in the place of V of P. Which is it? Right? This is the mean velocity is this V right here. Right? So we're replacing that with the 54.P. I mean, they say find the pressure. So we don't know the P, which is pressure. So we're substituting for the other thing, right? This is 54.5 time equals 6.3 times the square root of 1013 minus P. You know what 1013 is? That's sea level pressure. Okay, so now we're going to solve it. At this point, it's just a radical equation like the ones we solved on the previous page. So first step is isolate the radical. Divide by 6.3. And I imagine we don't have any calculators out, so let me do that. Clear. 54.5 divided by 6.3. 8.65, I'll call it 8.7. Since they were tenths, I'll do tenths. 8.7, that's a bad 7. 8.7 equals the square root of 1013 minus P. Okay, we've isolated the radical, then what? Square both sides, right? Square and square. Right, what is 8.7? Or I'm going to actually use what's in the calculator and just say squared. Right, answer squared, 74.8. 74.8 equals 1013 minus p. Solve for p. You know, if I add p to this side, it'll become positive. And if I subtract p to this side, then I'm going to do 1013 minus 74.8. 1013 minus, and you know what a calculator, if I want to bring up the last answer, then above the negative key right here, it says answer. So I just go second answer. 938.2. So that's a central pressure adjusted for sea level, 938.2. And what did they say was the speed? The mean speed was 74.8. Interesting. Okay, now we're going to do a problem which is actually not, it doesn't seem like a radical, but it is because it's a rational exponent. The first step is still isolate the radical. What do I have to do to isolate that radical? What's with, I mean, what is it there that represents the radical? X to the 2/3, right? What is it that's with x to the 2/3 that I need to move? The 4. So I divide a 4, divide a 4. Okay, now I've got x to the 2/3 equals 9. Okay, so we've isolated the radical. Next step would be undo the radical, right? So if I'm raising something to the 2/3 power and I want to undo it, I raise it to the 3/2 power, because then when I multiply, I get 1. Right? So now it definitely is, you know, raising to powers, x to the 2/3 to the 3/2. But if I'm going to do that on the left, I got to do the same thing on the right. Right? That is 9 to the 3/2. Okay, what's 9 to the 3/2? That's part of the homework last night, right? It's the square root of 9 cubed, which is 27, right? It's 27. So now we've got x equals 27. Now, if you go back, I think I've got this on the next slide. X equals 27. Okay, fine. If you go back to that slide, which is in the last lesson, do you see what it said there? It says when n is even, then actually when you do this thing where you take the nth root of x to the n, you get the absolute value of x. You don't just get x. And normally when you're showing this, teaching this stuff, you would say at this point, I don't just get x equals 27. I should have said I get the absolute value of x equals 27. And what does that make x? And clearly it could be 27 because the absolute value of 27 is 27. What else could it be? It could be negative 27. I mean, just go back and check it, right? If I go up here, if I put in negative 27, then the first thing, because of the denominator, I would take the cubed root. What's the cubed root of negative 27? Negative 3. Okay, then square it. What's negative 3 squared? 9. And 4 times 9 is 36. So we don't find all the answers if we only find the one. Now, to be truthful, if you look at their, you know, that yellow block there, that was cut from a bigger problem, which was multiple choice, which in a way kind of says, find the right answer that's in that list. I mean, they didn't have 27 and negative 27 in that list. They only had one right answer in the list. So if I was doing that multiple choice, there's no problem. That would definitely be a 27. But usually when you raise both sides to a power that has an even denominator, then you have to use absolute value symbols. You're going to be missing an answer unless you put in absolute value symbols. And again, that's because of that property right there. So, I mean, if you notice again, look at that side. When we were doing this just to simplify expressions, they said, okay, we'll just assume all the variables are positive. But that wasn't stated. These equations only look for positive answers. We really need to both. Right? So here's another example. Isolate the radical. Right? What do I have to do to isolate the radical? Add 1. Right? Now undo that radical. How do you undo raising something to the 3/4 power? You raise it to the 4/3 power, so that the 3/4 times 4/3, they cancel each other. You just get a 1. But if you do it to the left, you do it to the right. Now 8 to the 4/3, that's the third root of 8, 2 to the 4th power, 16. You could turn it into a radical or follow their math there, but the third root of 8, because of the denominator, is 2, to the 4th power is 16. There you go. Now, x plus 2 to the 3/4 to the 4/3, you multiply the exponents, they go away. Now you just got an x plus 2. Do I need that in absolute value symbols? Okay, notice this, I raised it to a power which had a 3 in the denominator. So that was a cubed root. So do we have the same issues? When it's odd, you don't need that absolute value symbol, right? You don't have the same thing, like the square root of 4 could be plus or minus 2, but the cubed root of 8 can't be plus or minus 2. It's just 2, right? So we don't have the same issue if that denominator is odd, no absolute values. And then you solve. And again, you could plug it in and check. Put in the 14 plus 2 is 16. The 4th root of 16 is 2. Cubed is 8. 8 minus 1 is 7. Check. So the first problems that we did, it was radical. The second, it was a rational exponent. So I'm going to do the number 5, and then you could try the number 6. Okay, so the first step, I'm going to divide by 3. Because I got to isolate. I've got x to the 3/2 equals 125. Okay, now I raised both sides to which power? It's x to the 3/2 raised to what power? 2/3. And that's 125 to the 2/3. That's bad. Okay, what's 125 to the 2/3? The cubed root of 125 is 5. 5 squared is 25. Okay, and over here we have x. So 25, that's it. So try the number 6. Isolate, undo the radical, solve. If there's any solving to do. On this number 5, when I undid the radical, it was already solved. Too easy. What did you do to isolate? divide by -2. So now we've got x to the 3/4 equals 8. Okay, now how do I undo raising something to the 3/4? Raise it to the 4/3. X to the 3/4 to the 4/3 equals 8 to the 4/3. X equals, what is 8 to the 4/3? What is the cubed root, because of the denominator, what's the cubed root of 8? What's 2 to the 4th? 16. So the answer is 16. It's not too hard, is it? Now, like I said, where it gets a little more difficult. Oh, what did I have that one to? I'm going to skip over those. So what I did in the last one, we raised both of those to the 2/3 power and 4/3 power. Since it was the denominator of 3 in both of those, in the end we were taking a cubed root. So you wouldn't have to think about the absolute values, right? In these here, what power am I going to raise both sides to? All right, let's just times it. What power am I going to raise both sides to in this number 9? 3/4, right? X minus 5 to the 4/3, all that raised to the 3/4. And then it's 81 to the 3/4. So this is x minus 5. But because it was an even denominator, that was taking a 4th root, which means that has to be absolute value. And what's 8 to the 3/4? It's 81. I was going to say, that's a bad number to use. 81 to the 3/4. The 4th root of 81 is 3/3 is 27. So now we have to solve an absolute value equation. That's x minus 5 equals 27. X minus 5 equals negative 27. So x equals 32. And x equals negative 22. And you can go back up and substitute them, right? If I put in 32 for x here, 32 minus 5 is 27. 27 to the 4/3 would be 81. If I put in negative 22, I'm going to get negative 22 minus 5 is negative 27. The 3rd root is negative 3. Negative 3 to the 4th is positive 81. So those are both answers. So you only have to worry about that when that denominator is even. If it's odd, you don't have the same issues. Now, these are the kind of problems that you actually have to worry about extraneous, right? And we saw something similar to that when we were doing absolute value equations. It wasn't all the absolute value equations that had extraneous solutions. It's when there's variables that are inside and outside the absolute value, or in this case, it's inside the radical and outside the radical. All right, that's when you might get an answer that when you solve, it doesn't check. So in this problem in particular, the radical is already isolated. So what do I have to do to undo that radical? I have to square it, right? So if I square that side, I have to square this side. So the square of a square root is 10x plus 9 equals, what's this x plus 3 squared? It's not x squared plus 9. Right, remember it's a x plus 3 times x plus 3, which makes that x squared plus 6x plus 9. Now remember that 3rd step of solving a radical. After you've undone the radical, then you solve what's left. And this is a quadratic, so you have to solve it like a quadratic. most of the time for quadratics, we're going to start with everything on one side in standard form, 0 on the other. So I need to subtract 10x, subtract 9, subtract 10x, subtract 9. And now I've got 0 equals x squared minus 4x. Okay, that's standard form. How do I solve? Nope. What do you do? Factor. That's why we spend all this time on factoring. X equals x times x minus 4. So what are the answers? 0 and 4. Now, if I go back up to here, right, and I check, if I put in 0, I'm going to get this, the square root of, right, this is for 0. I'm going to get the square root of 9 equals 3, and that checks. And then I'm going to put in 4, and I'm going to get, this is not really a good problem, is it? 10 times 4, that's going to be the square root of 49. Right. The square root of 49 equals 7, and they both check, which sometimes will happen, but you still have to check. Okay. I guess this one we'll have to do. Now, what's different about this problem than the one before? There's two square roots. So when it says isolate the radical, how are you going to do that when there's two radicals? When there's two radicals, first isolate one of them, undo it, and you'll still have one radical left, and you'll have to then isolate that one. So it's just a two-step process, right? In this case, if I square both sides right away, that will undo the radical on the right. Right? That's going to give me, on the right, it's going to be 3 minus x. On the left, I have to do the square root of x plus 2 plus 1 times the square root of x plus 2 plus 1. It's a FOIL. Right? The square root of x plus 2 plus 1 times the square root of x plus 2 plus 1. Right? What do you get when you multiply the square root of x plus 2 times the square root of x plus 2? X plus 2. Okay, then we're going to have the square root of x plus 2 times 1 plus another 1 times the square root of x plus 2. That'll be 2 times the square root of x plus 2. I didn't write that in there. 2. And then 1 times 1 is 1. So when I put all that together, now I've got x plus 3 times 2, or plus 2, times the square root of x plus 2. So now I have to isolate the other radical. Right? Subtract x plus 3. Right? And now I've got 2 times the square root of x plus 2 equals, and now the 3's cancel, I get negative 2x. Divide by 2, because I'm isolating the radical. The square root of x plus 2 equals negative x. So it's two steps, right? Isolate one radical, undo it. Isolate the other radical, undo it. What am I going to do to undo this radical? Square both sides. So I'm going to get x plus 2 equals x squared. Right? The negative times negative goes away. And now I can solve that by factoring. X equals, 0 equals x squared minus x minus 2. So you're left with a quadratic, and you've got to solve it like a quadratic. How does that factor? negative 2, positive 1. Right, so x equals, positive 2 and negative 1. Okay, now we've got to check. Right, we've got to go back and check our answers. And I'm just going to do it visually here. If I put in a positive 2, I get the square root of 4, which is 2, plus 1 is 3. If I put in a positive 2 here, I'm going to get 3 minus 2, which is 1. The square root of 1 is 1. So we got 3 equals 1. That doesn't check. All right, that's what we mean by extraneous. Right? I'm checking the 2. The square root of 2 plus 2 plus 1 equals the square root of 3 minus 2. That's a question mark. We don't know that. Right? The square root of 4 plus 1 equals the square root of 1. 2 plus 1 equals 1. Not true. So you would say this one right there is extraneous. Right? Extraneous. Okay, now we can check the negative 1. Negative 1 plus 2 is 1. The square root of 1 is 1 plus 1 is 2. 3 minus negative 1 is 4. The square root of 4 is 2. 2 equals 2. So this one checks. But the 2 didn't. So 2 is not an answer. It's an extraneous solution, which means it's not a solution at all. But if you're solving, you have to check for it. And usually the way I'll do a question like this to make sure that we didn't just like not check is I'll say find the extraneous solution. So you have to actually go through all those steps. Okay. So solving radicals. Isolate, undo, solve, check. That was it. That's homework.